This Zoom session is being brought to you by the fractal globe snow ring edge. Okay, for today, we will do 7.5, solving radical equations, and 7.6, the Pythagorean theorem applications. All right, let's proceed. So, if we have a radical equation, one with a square root it. So if we have square root of x equals a, you solve it by squaring both sides. Square root of b squared is 1b if b is at least 0, and x equals y implies that x squared equals y squared. However, the inverse does not apply. Two numbers may have the same square but not be equal. For example, -1 is not 1, but -1 squared equals 1 squared. Therefore, this squaring away all the square roots may create roots that didn't exist before. So you really have to check all of them to make sure your reasoning is valid. Rapid-sura. I'm moving this. Okay, gotcha. All right, so for example, square root of x minus 1 equals 2. All right, you solve that by squaring both sides and get x minus 1 equals 2 squared. So x minus 1 equals 4, x equals 5, and you check by plugging in. 5 minus 1 square root is root 4 is 2, it works. Root 5 equals, here's root y equals -3. Uh-oh. Well, I mean, right away you can tell that it can't be solved because square roots are always at least 0, but here it's supposedly being -3, which is not allowed. If you square both sides, you get at y equals 9, but square root of 9 is +3, not -3. So no solution for this one. So examples, here we go. Square root of 6x plus 13 equals 7. Square both sides, so 6x plus 13 equals 7 squared. 6x equals, which is 49. Subtract 13 from both sides. 6x equals 49 minus 13. 6x equals 36. Divide both sides by 6, and x equals 6. And again, you have to check that. Plug in 6 into here. You get square root of 6 plus 13 is root of 36 plus 13, which is root 49, which is 7, which checks. So x equals 6 is, in fact, the solution. Now this one, watch out. Root of 2r minus 3, and that plus 9 equals r. Now, it's a little early to square both sides because you get cross terms. What we do is we transpose the 9, we subtract 9 from both sides. So root of 2y minus 3 equals r minus 9. Now you square both sides. That squares away the square root here. 2r minus 3 equals the square of r minus 9. All right, so 2r minus 3 equals, expand this, you get r squared minus 18r plus 81. Subtract 2r from both sides, add 3 to both sides, and you get 0 equals r squared minus 20r plus 84. Now, all right, okay, we have to factor this, and these two numbers, whose sum is -20, and whose product is 84. -6 and 14 work. So 0 equals r minus 6 times r minus 14. All right, so either r minus 6 is 0 or r minus 14 is 0. So r is 6 or r is 14. And we need to check both for it to work. Check r equals 6. The left side is root of twice 6 minus 3 plus 9. Root of 12 minus 3 plus 9 is root 9 plus 9 is 3 plus 9 is 12, and that is not equal to 6, which is the right-hand side. Check r equals 14. Left side is twice root 14 minus 3, that plus 9 is, after a bit of work, root 25, that plus 9. 5 plus 9 is 14 equals the right side, and yes, it works. So r equals 14 is the solution, and 6 is a spurious root, or I also call it extraneous. If we'd had a negative in front of this, then it would have worked fine, but it wasn't. Cube root of x cubed minus 7 equals x minus 1. Now here, we cube both sides, and cube root of a cube of a cube root is cancels out. For this one, we probably won't have to worry about spurious roots because square roots, cube roots are well behaved for negative numbers. Okay, so you cube both sides. Left side is x cubed minus 7. Right side is x minus 1 all cubed. So x cubed minus 7 equals x cubed minus 3x squared plus 3x minus 1. This is what you get when you expand the cube of x minus 1. All right, subtracting x cubed from both sides cancels it. Adding 7 to both sides, we get 0 equals minus 3x squared plus 3x plus 6. Well, there's a lot of factors of 3 here. Let's divide by -3. both sides, and you get 0 equals x squared minus x minus 2. Now, okay, to factor this, we need two numbers whose sum is -1 and whose product is -2. -2 and +1 fit the bill. So 0 equals x minus 2 times x plus 1. So x minus 2 is 0, for x is 2. X plus 1, or x plus 1 is 0, for x equal to -1. Okay, so let's check both. Check x equals 2. The left side is cube root of 2 cubed minus 7, which is cube root of 8 minus 7, which is cube root of 1, which is 1. And the right side is 2 minus 1, which is also 1. So it checks. Check x equal to -1. The left side is a cube root of -1 cubed minus 7, which is -1 minus 7, which is cube root of -8. Fortunately, cube roots don't mind negatives, so this is in fact a -2. The right side is -1 minus 1, which is -2. Again, these check. So we have two roots, x is 2 or x is -1. Here we have a mess. 3 equals square root of y plus 4 minus square root of y plus 7. The difficulty here is, of course, if you square both sides, we get a cross term, which will still have a square root. What we do is simplify it a bit by transposing the y plus 7 to the other side. You add root y plus 7 to both sides, you get 3 plus root y plus 7 equals y root of y plus 4. Now, okay, when we square both sides, this square root goes away, but we'll get a square of a sum, which gives you a cross term. Square of 3 plus root y plus 7 equals root y plus 4 all squared. Root y plus 4 all squared is just y plus 4. The square of a sum is square plus twice product plus square. 3 squared is 9. 2 times 3 times root is 6 root y plus 7. And here you have a root y plus 7 all squared. All right, get rid of this square away this root. 9 plus 6 root y plus 7 plus y plus 7 equals y plus 4. Okay, we still have a square root, but there's only one. And we can isolate it. We subtract 9 from both sides. We subtract y from both sides. We subtract 7 from both sides. Subtracting 9 from both sides cancels it out. On the right, we're left with 4 minus 7 minus 9, which is 6 root y plus 7. All right, subtract these out. 6 root y plus 7 is -12. Divide by 6. Root y plus 7 equals -2. Oh, after all that work, we have a square root being negative, and that can't happen. Square roots are always at least 0. So, no solution. 3 root 5n minus 9 equals root of 5n. All right, square both sides. Square of 3 root 5n minus 9 equals square of 5n. Square distributing over these, the square of 3 is 9. Square of the square root will just be 5n minus 7. Square of the square root is just 5n. Okay, we now have a simple linear equation. Distribute the 9 over these two terms. You get 45n minus 81 equals 5n. Transpose the 5n to the left and the 81 to the right. Get 45n minus 5n equals 81. 40n equals 81. N equals 81 over 4. Well, all right. And if you plug in both sides, you can get a bit of a mess, but in both cases, you get 9 over root over twice root 2. So it works, and N equals 81 over 40. Now here's a slightly different one. Instead of 3 times root 5n minus 9, it's 3 plus root 5n minus 9 equals root 5n. You can see these are two what they call lookalike problems. Well, again, we'll square both sides, but we'll get a cross term on the left. Square of 3 plus root 5n minus 9 equals square of root 5n. Root 5n squared is 5n. Square of a sum is square plus product plus square. 3 squared is 9. 2 times 3 times the root is 6 times the root. The square of this root is the square of this root. We square away the root. So you get 9 plus 6 root 5n minus 9 equals 5n, plus 5n minus 9 equals 5n. Oh, we transpose the 5n, 9 and -9. So you get 6 root 5n minus 9 equals 5n minus 9 minus 5n plus 9, which all comes out to 0. 6 root 5n minus 9 is 0. Dividing by 6, you get root 5n minus 9 is 0. Square away the root. 5n minus 9 equals 0. Transpose the 9 and the 5, n equals 9/5. How can we check that out? The left side is 3 plus 5 times 9/5 minus 9. This cancels out to a 0. 3 plus root 0, and that's just 3. The root, the right is root of 5 times 9/5. Well, that's root 9, which is 3. These check. So n equals 9/5. Now, cube root of p over 0.02 equals 29. Cube both sides. P over 0.02 equals 29 cubed. Transpose the 0.02. P equals 29 cubed plus 0.02, which is 487.78. And that's the answer, 487.78 watts.